Hello, my name is Aaron Fields. This presentation is entitled New and Upcoming Security Features. It's based off of the Tangled Web Chapter 16, and it's for INFA 729 Advanced Web Hacking with Dr. Josh Pauli. So, the internet as we know it is an okay place. It's not a super secure, super safe place, but it could be a lot worse. Rebuilding a secure internet would be great, but we all know that that would be a ton of work. And so what we keep doing is, instead of rebuilding a new internet, we just keep adding code and complexity to what we already have. Now that does allow us to mitigate classes of vulnerabilities, and a lot of times what people will do is build kind of stop gaps for really tough problems that nobody wants to solve right now. Also, a lot of times people add code to enable new applications to be built in the future. So that's kind of where we're at right now, and that's really where we're going to be at for a while, because the risks of adding complexity to the code that we already have are almost always outweighed by the benefits that we gain from adding that code. So in this talk, we're basically going to be discussing three basic categories. The first is the security model extension frameworks. And so what these do is add flexibility to the same origin policy, kind of opening up boundaries that were previously closed. The security model restriction frameworks kind of do the opposite, right? They add new rules, new boundaries, etc. And then we have the other category, which we'll get to when we get to. The first security model extension framework is called cross-origin request sharing, or CORS. Originally, cross-origin requests could be made with image, script, or iframe tags. The problem was that client-side scripts didn't have access to the content of those resources. They could only be executed and rendered by the browser, which sometimes caused problems for developers. So CORS enables JavaScript to read the content of foreign sites or resources through something called the response text property. Now, plugins like Flash and Silverlight, etc., are allowed to make cross-domain requests and read the response. However, the access control mechanism for plugins like that is entirely different from core. With those plugins, either you allow a domain to make a request to your site, or you don't. It's kind of a domain level sort of deal. You can't filter on a page-by-page basis. However, with cores, each individual page has to respond with an access control allow origin HTTP header. And actually implementing CORS on a server is just as simple as that, enabling that header. So I'll actually show you guys how to do that in just a second. That header actually relies entirely on a mandatory origin header, which is issued by the XML HTTP request API from the client. There are two types of requests that API can make. One is called simple, one is called non-simple. In order to qualify as a simple request, the request must be using get, post, or head. And if there are any custom headers, they have to be cache control, content language, content type, expires, last modified, or pragma, nothing else. Simple requests, from what I understand, are submitted to the server immediately. There's no extra checking, verification, or anything, as long as the access control allow origin header and origin work together. Non-simple requests are a little bit different. They do something called a pre-flight request, because most of the time non-simple requests are using either a method that's different from get, post, or head, or they have different custom headers that aren't in that list that I previously mentioned. So non-simple requests will do something called a pre-flight request to make sure that the server is compatible with the client. Enabling CORS on Windows Server 2008 is as simple as going into the inetpub directory, www.root, and then editing your web config file. Now, if you don't have one, if you don't have a web config file, you just need to add one, and you need to make it look like this. If you've got other stuff in there, this custom headers tag is what you need to worry about. Now, notice the value here. I put a star for the value, which means allow anyone to access this content using JavaScript. So we can go ahead and test it out here. Right, here's a response from my server, and there's the star and the header. Sweet. I do want to show you some examples of cores in action on some real websites. So the first example I'm going to show you is a simple XML HTTP request to a different domain. So you'll notice we're on a runranga.com right now. If we look at the page source, URL, a runner.net, this is going to be the domain that we're requesting content from. This is the code in order to request that domain using XML HTTP request. So we click the button, we catch the request. You'll notice the origin header, which is set by XML HTTP request itself. Forward this on to the server. We get a response, access control allow origin, a runranga.com, sending it back to us because, well, we are on a runranga.com. Cool, it worked. Now let's just watch what would happen if we tried to do this exact same thing from a domain other than a runranga.com. So we'll click the button again, catch a request, but this time we'll change it to google.com. How about that? Forward. Uh-oh, we got something different this time. Server noticed that the origin header didn't match, and so it's sending us back different stuff. And the JavaScript on this page knows that, and so it says invocation errors occurred. Cool. Now let's take a look at a non-simple request. Alright, so this page, take a look at the source code real quick. Another XML HTTP request. However, this time it is using the post method as well as adding an extra header called xpingarunger with a value of ping pong. So not a standard header, not one of the ones that's required for a simple request. So let's see what happens when we fire this off. We get the pre-flight request, right? So you'll notice it's using a method called options, and it just sends basically a sample request to the server with the headers that it wants to use. So we'll forward this on to the server, and the server replies saying, yep, like here is what I allow. I allow these methods, post, get, options, and I allow these headers, xpingarunger and content type. It also has an access control, max age. So we'll forward this on, and then this is a request to the server again from the client with the actual request. You'll notice it's a post request like we saw in the code. Origin is a runranga.com. Forward it on. There we go. We got what we wanted. It worked. So the interesting thing with non-simple requests is that if I click this button again, notice that it just posted right away. It did not send the options request again. That's because the server's responses to the options requests can actually be cached on the client, so that the client doesn't have to cause unnecessary strain on the server, etc. The amount of time that the options response can be cached on the client is based upon the server's max age header, which you saw a couple of requests ago. So far, course seems to be a pretty robust framework. However, there are a few complaints. The first comes primarily from Microsoft. Basically, they're saying that CORS is based solely upon the origin header, which is true. And they're saying that that is an abuse of ambient authority. If you're not familiar with ambient authority, it's basically the concept of access being controlled by a name and a method, and that's it. No passwords or anything like that. And Microsoft is basically saying that if something requires authentication to transfer data, you should be using explicitly exchanged authentication tokens, not just domain names. Second big complaint is that CORS is needlessly complicated. This is somewhat true, especially so concerning the pre-flight requests in non-simple requests. Nobody has really come up with any good use cases to justify the use of that options request just to allow a developer to use, extra random headers. There's just not a lot of uses for it, evidently. The third and most serious complaint as far as implications is that CORS is susceptible to something called header injection. So if there's a header splitting vulnerability in the server-side code, which is basically where a user's input can be returned back from the server in a header, it would be very easy to create multiple access control allow origin headers and allow new origins, and open up a whole plethora of issues there. However, as long as your website isn't vulnerable to header splitting, this isn't even a vulnerability. Because Microsoft isn't a huge fan of XML HTTP requests and CORS in general, they decided to come up with their own solution to their complaints, and it's called XDomain request. So it's really pretty simple, and it's actually even easier to use than XML HTTP request. It's basically XML HTTP request without the non-simple requests. So it'll only do simple requests. It'll present the server's response only if the access control allow origin header matches the origin. So it's simpler, it's theoretically safer than XML HTTP request, and it works for pretty much every plausible use case that people have come up with so far. The only problem is that it's amazingly unpopular, and it's only supported in IE8 and higher. Alright, moving on to security model restrictions. Extensions, first of all, typically fail securely, right? Like if it's not supported in a browser, more restrictive logic, the older logic, is going to kick in and take care of things. But adding new restrictions is a little bit more dangerous, because if a browser doesn't comply with the restriction, then it fails open. The first restrictive framework that we're going to talk about is something called Content Security Policy, or CSP. What this allows you to do is to define per document policies, access restrictions, on a page, right? And those restrictions are defined in either a new server header called Content Security Policy, or in the meta tags of the HTML, or you can link to the policies externally using policy URI. So CSP is really great because it allows developers to control what a page can load, and even restrict things from loading that would have normally been allowed under the same origin policy. So in this example, default source is set to none, which means that no external resources are allowed to load on the page. And image source is set to http star.example.com. And that means that images are the one exception on the page. They can load images, but they can only load images from star.example.com. As of now, CSP can provide control over scripts, plugins, style sheets and fonts, passive multimedia like pictures, for example, and subframes or iframes. Probably the most important item in this list, however, is the default policy. Basically, it specifies the fallback policy for when content on the page is not covered by a more specific directive, like scripts or plugins or whatever. And the default policy is required no matter what if you're using CSP. Frame ancestors is kind of an oddball. Basically, it's supposed to help mitigate clickjacking attacks by mandating whether or not a website can be framed by a frame ancestor, which is essentially like a parent. So the frame ancestor directive is entirely independent of all the other directives, including default policy. Frame ancestor's default value is actually a star, which means that the site can be framed anywhere. So if you're using CSP and you don't want your site to be framed within other websites, you definitely want to change this right away. So there are a few criticisms of CSP, and the first is that it's not very future safe, right? There's always new tags being added to HTML, and there are quite a few already, including favicons, that are simply not supported by CSP at all. Another big issue is that developers are going to have to retrofit all of their code, which is going to be a pain, because they're going to have to move all inline scripts to a separately requested document. And same thing goes for style sheets. And that's a lot of work, and it also sucks because each time a page is loaded, there's going to have to be at least a few extra HTTP requests to get the client all the documents that they need. So a little bit of extra strain on the server side. There is a potential solution to this problem that's currently being talked about in more recent drafts of CSP, and it's something called a script nonce. And basically, it would allow you to still use inline scripts, but each block of script would have to begin with a policy-specified unpredictable token. And the reason for this is that, if there's an inline script on a page, there's no way for CSP to tell if that inline script is supposed to be there and it was put there by the developer, or if it was somehow injected into the page by an attacker. Another criticism of CSP is that it uses origin level granularity to allow or deny resources. And people say that that's not enough because it does prevent straight up cross-site scripting across domains. However, an attacker could still load a script in the wrong context across the same domain or in an incorrect sequence, which can cause some serious problems. Another pretty serious issue has to do with these things called JSON callback APIs. Basically, these things allow a user to specify a callback function when they visit a URL. So it's a function that's loaded on the page that is supposed to get called when a user gets that page. So theoretically, an attacker could use this to call whatever function on the client that they want to call. And they could even supply their own parameters to the function via, the URL. Also, if the callback parameter is not filtered properly, it's possible just to get straight up code execution. So where it says function name on that slide, you could just put a simple alert, right, and get code execution, assuming that the input is not filtered at all. So the next restriction framework that we're going to talk about is sandboxed frames, and this is an extension to iframes, but it restricts the permissions in iframes. So by default, a sandbox iframe basically just blocks everything. Scripts, top navigation, same origin, forms, etc. But those restrictions can be lifted by using those parameters down below: allow scripts, allow forms, etc. So the concept of sandbox frames was actually developed by Microsoft as early as Internet Explorer 6. So if as a developer you put a security equals restricted parameter on an iframe, the browser would load it in Internet Explorer's restricted zone. I'm sure some of you guys are familiar with that. But that means that it wouldn't be allowed to execute any scripts, navigate to other locations, etc. Sadly enough, that was actually used primarily for bypassing frame busting defenses. Amusingly enough, this new sandbox restriction can be used for frame busting as well. So we have a page here, framer.html, with an iframe that is entirely sandboxed, no permissions whatsoever. And I'll show you the frame busting code in the page that is to be framed. It basically checks to see if the self, which is this page, is the same as top. If it's not, it sets the top location to itself. The problem is, when you load this in a sandbox, this JavaScript can't run, and so it gets framed. There is a solution, however, that some geniuses, Gustav Reidstedt, I don't know how to pronounce it, Ellie Burstein, Dan Bona, and Colin Jackson came up with. All you've got to do is add this line, which is some CSS, to basically, by default, make the page display nothing, right? And then if self does equal top, the CSS will change using this line to block, which will make it look normal, right? So now, if we try loading this again, this page right here simply doesn't show. The JavaScript isn't running, but because of this style, the page just isn't going to show. And just to show you what happens without the sandbox, just so you can see the whole URL here. So we're going to framer.html. However, if that JavaScript is allowed to run, it changes the top or the parent to the source of the frame. So hopefully that kind of makes some sense to you guys. So if you have a website that you don't want to be framed, you should definitely use this code. You could also consider using the frame ancestors directive of CSP. By default, sandbox frames are given something called a synthetic origin, hence this allow same origin directive here. So synthetic origins, they cause a lot of problems. The idea behind them is to allow untrusted documents to be delivered along with potentially sensitive information, but to prevent those things from being able to touch each other, essentially, right? So you don't want to let the untrusted document access the sensitive information that it's being sent along with. So the first problem that the author of Tangled Web mentions is that unless the URL is unpredictably random, an attacker can just open the link to the embedded document in a new window, which means that the page is no longer sandboxed. So to combat this, developers of synthetic origins came up with a new MIME type. It's called text/html-sandbox. And it's for content that's meant to be shown only in a sandbox frame. The idea was that browsers wouldn't render any content marked as HTML sandbox unless it was inside of a sandboxed iframe. Of course, the problem is that all browsers and plugins handle and render HTML sandbox differently, or they just have problems with it. One thing that the author also mentioned in the book is that there are a lot of issues because of the fragmentation of origin and domain level security mechanisms in most browsers. So the example that he gave was like password managers. They need to somehow be explicitly prohibited from auto-completing login forms in sandboxed documents, because they shouldn't be doing that. There are also problems if you remove synthetic origins altogether. For example, if a user clicks on a same site link in a sandbox advertisement and that link opens in a new window, that new window can use the window.opener object to interact with the parent window. That's bad. Now, what I think is a very cool restrictive technology is something called HTTP Strict Transport Security, or HSTS. So when your average Joe goes to Facebook, they don't type in HTTPS www.facebook.com. They just go to www.facebook.com. What happens is that when you go to www.facebook.com, you get an unencrypted session with the website, not over SSL, and then you're redirected to a secure SSL version of that website. And that sucks because if you're being actively man-in-the-middled, the man in the middle can prevent you from ever upgrading to HTTPS using something like SSL Strip by Moxie Marlinspike. So HSTS aims to change that, and basically it does that by adding another header to the server's HTTPS response saying, hey, always use HTTPS when you connect to me. So basically this works on the premise that if the first time a user visits a website, it's likely that they won't be man-in-the-middled the first time, and that they'll be safely upgraded to HTTPS and get this header. And then as they continue to move around from network to network, the browser will remember to use HTTPS for that given domain, even if that user is being actively actively man-in-the-middle. So you'll notice on the second point there's the max age variable. Basically this contains a number of seconds that a browser is supposed to remember to continue to use HTTPS. Once it's sent to the browser, it's not resettable, so it's very tempting for developers to set it to a lower value just in case something goes wrong with their HTTPS site, because they'd have no way to redirect users back to HTTP. Also, the include subdomains parameter is pretty interesting. If you don't use it, it's actually possible for an attacker to capture cookies by creating a non-existent subdomain and intercepting HTTP requests made to that destination. Book talks a little bit more about that. But this is a sweet method for mitigating the risk of man-in-the-middle attacks. With that said, however, there is a slight risk of DOS attacks. If an attacker is able to inject that strict transport security header into a domain that's not fully HTTPS enabled, right? So using header splitting, which we talked about earlier, that user, whoever happens to get that header, they're not going to be able to load anything on that website for quite a while. There's also the potential for HSTS to be used to track users. And I don't understand this very well, but from what I do understand, basically the HSTS host, right, so the server, can encode information into domain names that is controlled by the administrators of that server, and it'll cause users to cache that information in their HSTS policy store within their browser, which is where the browser remembers what sites to use HTTPS with and which ones to not do. So the idea with this is that other hosts, other servers, could cause the user to make requests to variations of the original HSTS host's domain name, revealing whether or not the user has already visited that domain or subdomain. So basically you could check to see where people are going on the internet. So the author also says that HSTS probably doesn't work well on plugin based requests and content. The last restrictive framework that I wanted to talk about is private browsing. Most browsers have some sort of private browsing feature, and this is meant to be a non-persistent browsing sandbox that's entirely separate from the main browsing session. Kind of a problem with this, though, is that people assume that it's completely anonymous and that no data will persist on the machine. But this is entirely false. Private browsing works well for kind of hiding stuff from other non-technical users of the same machine. But the real problem is that with all the different protocols and plugins and extensions, etc., that browsers have, it's very hard to effectively sandbox all that information, right? Like geolocation in browsers has to be sandboxed. Ch16 has to be sandboxed. Auto-completion, for filling out forms has to be sandboxed. Plugins, persistent data on the hard drive needs to be sandboxed. Even more like JavaScript, it's possible to use JavaScript to fingerprint browsers based on what plugins or extensions they have installed, what version of browser somebody's running, screen resolutions, window sizes, clock drift, just all these little variables make it very hard for private browsing to actually be effective. We're finally to the other category. So we're going to talk about in-browser HTML sanitizers and cross-site scripting filtering within browsers. So you see here on this page, sandbox token equals random value 1, 2, 3, 4, 5. And then you notice at the end of the tag there's another token which equals random value 1, 2, 3, 4, 5. So something like this would be really cool, right? Any unsanitized content could be put inside of a sandbox like this. The sandbox has restricted permissions, of course. And for an attacker to escape that sandbox, they would have to, inject like closing tags with this random token value. So they'd have to guess the random value. But alas, the author says that this is basically never going to happen because for it to work properly, XML itself would have to be revised in order to be compatible. I don't know enough about the web or about XML to know why it would have to be revised and why that would be such a big deal, but hopefully someday we could see something like this implemented into XML and then browsers. Right, cross-site scripting filtering. So at some point people decided that detecting and stopping cross-site scripting was better than just reducing or limiting the impact of it. So in 2008, a guy from Microsoft named David Ross announced the inclusion of cross-site scripting detection logic in Internet Explorer 8. A few months later, a guy named Adam Barth implemented a similar feature into WebKit browsers. And basically what these scanners do is look at the URL for strings and then compare those strings to strings that are found in the page or strings that are being passed to the document.write method. And if it appears that a portion of JavaScript present on the page may have come from an improperly escaped URL parameter, the browser will replace the string on the page with something harmless. So basically, Internet Explorer 8's filter was just horrible. It actually introduced new cross-site scripting vulnerabilities where there were none before. So I'm not going to go into great detail about this, just for sake of time, because this video is already way longer than it should or needs to be. But I would definitely recommend checking out the paper that I have listed in the slide there. But I'm just going to show you a really quick website here. Right, cross-site scripting filtering. So at some point, people decided that detecting and stopping cross-site scripting was way better than reducing or limiting the effects of cross-site scripting. So in 2008, David Ross of Microsoft announced the inclusion of cross-site scripting detection logic in Internet Explorer 8. And a few months later, Adam Barth implemented a very similar feature into WebKit. Basically what these features do is scan the URL for strings and then compare those strings to strings on the page or strings that are being passed to document.write. If the strings or if it appears that a portion of the JavaScript present on the page may have come from an improperly escaped URL parameter, the browser will actually replace the string on the page with something harmless. So in Internet Explorer's case, it puts just a pound symbol there. So Internet Explorer 8's filter was actually horribly terrible. The filter actually introduced new cross-site scripting vulnerabilities where there were none before. I'd love to go into great detail about this, but I'm not because this video is already way too long. But you can check out the paper that I've listed there in the slide. It's really sweet, goes into a lot of detail, and has some cool demos. Of course, you've always got the issue of false positives with browsers. So I just want to show you a little example with Internet Explorer here. If we paste in this URL, which is in the slide, google.com/search, and then with the parameter q, which equals a script tag. That's just been URL encoded there. Hit enter, and yeah, that's a false positive, because in Chrome, this is what you get. You're searching for script. So you know, that's kind of an issue. To help combat some of these problems that people were having with these filters, Microsoft actually made another new server header. It's called cross-site scripting-protection. So basically, the first example here in this slide says to the browser, use the filter. According to the author of the book, this is different from the default setting you'd have if you don't use the XSS header at all, but I honestly don't know what is different about it. He didn't specify. I think it just blocks the whole page from even rendering if XSS is detected, as opposed to you know, just filtering out certain bits of it or replacing strings. The bottom second example there basically says don't use the filter ever, period. So it's kind of an opt-out of the cross-site scripting filter. Well, that is about all I had for you guys. I will put my sources in the description of the video if you'd like to check out my sources. There is lots of good stuff to read out there. But anyway, I guess I thank you for watching this video. See you next time.